My name is Jakub Warczarek, and I will tell you how to answer tricky questions the SRE way. We are on a DevOps conference, so definition of SRE can be really short. Site reliability engineering, the specific implementation of DevOps with some idiosyncratic extension which treats operation as a software dev problem. We can think about whole DevOps as an interface and about the SRE as a specific implementation of this interface when we want to have the software development analogy. So what are those extensions? There are three of them. SLI, Service Level Indicator, measurement of services behavior, for example, request latency, batch throughput, failures per request, etc. Basically, it's a metric which we collect and it's tightly coupled with the satisfaction of customer, with the health of our platform. Based on this metric, we create SLO, Service Level Objective, agreement among stakeholders. It's the product, developers, DevOps, management, etc. That, for example, 99.95% of requests to our platform should end with a status code 200. All should finish under half of a second. This SLO should correspond with the customer happiness. And the last but not the least, error budget, what to do when a system is not meeting its reliability goals. So we do not hit 99.95%. So what we are doing, and everybody agrees on it, that for example, we stop the feature development and we put extra effort on making our platform reliable to not lead to happen this situation again. It may sound familiar for some of you to SLA, Service Level Agreement, but it's a little bit different because SLA is a business agreement between a customer and service provider, typically based on SLO, and usually offers a lower availability than SLO because we want to have safety margin to avoid penalties for not meeting them. Moreover, SLO you should think more about as an internal tool to have meaningful conversation in your company rather than punish someone. So, why you shouldn't aim for 100% of reliability? Because basically it's an overkill. Faster feature development and shipment is more important for customer than 100% reliability. Short outages are indistinguishable for a user from, for example, a Wi-Fi router being slow or something like that. They even don't notice it at all. And providing high availability or speed when end user cannot experience it is pointless. Because, for example, let's have a mobile application which is used from as mobile application from mobile phone which connects to the backend through the cellular internet connection, which is flaky, which is crappy, and even when your server serves the request very fast and it's high available, your customers don't experience it due to the connection. So know what to measure. And being reliable is costly because adding 1 9 requires us to be 10 times more reliable, so 10 times better. Being 10 times better is always hard and it costs. And story about Google Chubby, which happens in Google. Chubby is a system at Google which provides log service. You can think about it as, for example, Zookeeper from the open source world. Has certain SLO, but it always is far more reliable. Is it good? No, because other system treats it as 100% reliable and have hard dependencies to it, even if they don't need to have them. Google learned it hard way that chubby outages leads to a big failure in other systems which are depends on it. So now SRE and Google make sure that Chubby meets but does not significantly exceed its SLO. In this way, they are able to flush out unreasonable dependencies on Chubby shortly after they are added and make the system as a whole, so not only Chubby but are the stuff which depends on Chubby, more reliable because they can cope with the unavailability of Chubby in a graceful way. So when speeding up application 2 times doesn't improve user experience, let's consider this simple example. We have our application which gather data from third-party system. We don't have any control of this third-party system. Next, there is the processing pipeline, which saves the data to the database and serve data to users. Someone has an idea to reduce processing pipeline delay from 1 second to half of the second, so 2 times. It is great, but delay of third-party system is 2 minutes. So even if we can be 2 times faster in the processing, our customers don't experience it because the bottleneck is the delay of the third-party system, which we don't have control over. So basically, instead of optimizing this processing pipeline, we could spend our time better. By the way, speed is subjective. Everybody knows that red car are faster. Great talk, but Ignite talk, but Steve Souders, The Illusion of Speed. I highly recommend it. And what should wake up on-call engineers? Because by the end of the day, they are responsible of reliability of the platform. Alerts, of course, which will be triggered when SLO may be violated. Only when SLO may be violated. Of course, for SLO, which corresponds with user happiness satisfaction. Metrics like, for example, CPU usage, disk space, and so on, when they are not affect our customers, the SLO, we shouldn't wake up engineers to fix it. Maybe we can live with this with a couple of more hours. You can detect a risk of burning the entire error budget. You should observe the burn rate to be able to react proactively. For it, burn rate tells us how fast we will burn the whole error budget. So basically, we should alert only on it and making changes in our platform to fix it to avoid violating our SLOs. So key takeaways from my Ignite talk. Measure exactly what users need from you and focus on delivering it. SLI, SLO. Have discussion and make decisions based on this data. Nothing is perfect all the time. Be reliable enough that a casual observer might think that it's up 100% of the time. No one is perfect. Nothing is perfect. No one expects perfection all the time. That's all. Thanks.